G'day everybody and welcome back to my channel. Right, so we're going to get a move on with this Yamaha mixer amplifier. Now, when I had a first look at this, just for those that haven't watched the first episode or might not remember too much. Sorry, I thought I just saw something. I had to have a look. I showed that this thing doesn't want to power up, but if you sit there and press the power button repeatedly, eventually it turns on for longer periods of time to actually boot, like, well, it boots like this. It's not processor based. Mate, well, the signal processing stuff in the front end is, but you know what I'm saying. It turns on and how do I explain this? It turns on, but it only basically powers up, I'm guessing, the plus minus 15 volt rails, because yeah, there's no other rails that are actually, let me just go get the front panel, because I just gotta have a quick read of something. Okay, there's no way I'm going to be able to read that. Maybe on the power supply board. Yes, on the power supply board. Yeah, so there's also a 12 volt and a 5 volt rail that goes to the front panel on top of a plus or minus 15. But here's what I've discovered. I think we powered it up and we disconnected the power leads to the power supply from the amp module. So the amp module was literally just connected via the plus minus 15. And I'm pretty sure I disconnected the front panel because it would power up without the amp module, and it would power up with the power wires to the amp module disconnected. It would power up with the front panel connected. It would power up with this disconnected. Sorry, this was the thing, the small ribbon cable that goes from the power supply to this board here. When that's plugged in, the power supply doesn't want to turn on. Right, so incidentally, that cable carries the clip B, clip A, fan, thermal, mute, you know, DC protect. So a lot of stuff here comes from this board and tells the power supply, hey, turn off, something's not good, right? So I'd say this is where the problem is. Actually, I'm an idiot. I forgot to put my hotspot on, so I meant to get the data sheet for this chip. This chip here is going to be most likely the speaker protection IC. And I need to get the data sheet for that because, well, what I'm planning on doing is powering up the plus and minus 15 volt rails and first having a look at the current draw on both of them. Is one side getting pulled down? If not, and everything's kosher there, well, I need the data sheet for this chip, the speaker protect IC, so I can see, well, what it's supposed to see for good conditions and what it's supposed to see for bad conditions. And then I can probe its pins and see what it's getting, right? And then I can follow that back. The fact that it still goes into protect with the main power wires disconnected doesn't necessarily mean a lot, because here's the thing, right? Because the plus and 15 volts still comes in, even just having the op amp there powered up and some low voltage stuff powered up, like maybe some current sources, current mirrors, maybe a buffer stage that's done out of discrete transistors, that if there's something wrong there, and that's you know, DC positive or negative, not, you know, 0 volts, and that's passing through, that will still pass through the base to emitter resistors and all the junctions to the output, and the speaker IC could still see that and think there's DC on the output. It's not necessarily coming from the output devices or even their drivers being shorted. It could be coming from something further back in the circuitry. And the fact that it doesn't want to turn on with the power rails to the output stage disconnected makes me kind of think that that's what's happening. But, you know, we're not going to know until we have a look. So, excuse me, I'm going to go get 3 little wires so I can stick them in that hole there, and we can power it. Let's see. I'm trying to get 3 different coloured wires that make sense for everyone, because when I work on my own, I'll do dumb stuff like use 3 black wires or 2 blacks and a red or whatever I grab, but so everyone actually that's watching can actually see what's happening. It's a split plus minus 15 supply. Right here, the yellow is the 0 volt, middle reference, whatever you want to call it, ground reference. Right, just move that out the way. So what I've done is I've got this over here. This is set at 15 volts a side, so 30 volts across. And as you can see, it's not in auto tracking mode, it's in independent mode. It's just hooked up in series, so I've got, you know, plus minus 15 here. And I've already set the current for 20 milliamp limit each side. So actually I'll just grab the leads. And yeah, I've given it a rudimentary test. I feel pretty confident this power supply is safe. Let me tell you now, that's got better regulation on volts and amps, less ripple and less noise than that there, and that. So yeah, anyway, I'm just going to short out the 2 rails and you'll see what I'm saying. So that side's limited at 20 milliamps and that side's limited at 20 milliamps. Was that other side a bit shy? Yes. That's better. Right, so I got 20 milliamps each side here. Sorry about my phone's focus. I'm going to bring that over. Should have just left it. Put this back here for you guys. Plug it in so it doesn't go fat. Seem to have moved my, stuck my hand into my computer fan based solder fume extractor. I'm just gonna plug my phone in so it doesn't go flat. Right, so I'll just pause the video, get some alligator. Actually, no, they're right in front of me. What am I saying? I don't need to pause the video. Right, cool. Try and grab colours that make sense again for you guys. I just want to test some of the alligator leads I've got. I make myself. These ones I have no doubt over the fact that they're good, but these cheap ones that come from J-Car, they go open and all sorts. The wire's piss weak, can't handle any current. The solder connections are poor. So I'm just going to do a quick check on my multimeter and just make sure that this green lead's okay. It'll do. Right, so we've got that there. Good enough for Australia. Well, that is quite interesting. I'm really shocked over that because it's pulling both sides down completely. You know, it could just want more than 20 milliamps, that's possible too. Yeah, wow. Let me just see if it needs a bit more current. No. Huh. Well, that's not good. Oops. Just want to double check my power supply is doing what it's supposed to do. Since I did just fix it. I'm an idiot. I've already got the meter on current. I thought it was on voltage, and when I connected it, it pulled it down to 0. It's on current. It's not taking anything. My bad. Oh, I feel like an absolute dumbass now. I can't believe I just did that. Okay, so it's not taking any current. All right. So, well, that's good news. There's no dead short. All right. I'm going to pause the video and get the data sheet for this IC because that's the first place I want to start probing around. I want to have a look at what that's doing. And, well, after I get that, depending on where things go, I'll either be getting the schematic for this amplifier or, yeah, it depends what I see on here. So I'll just pause the video, get my internet on, get the data sheet for that. I'll be back in a moment. Okay, well, that just turned to shit real quick. That's just 4 comparators. It's a BA10339F. It's just 4 comparators open collector output in one package. That's obviously being used for speaker protection. What they'd be doing is they'd be setting a reference voltage, which would be the threshold, which, you know, whatever they've decided is the maximum allowable offset that's tolerable on the outputs. That would be on one input pin, and the other input pin would be looking at, you know, each amp stage for that, its output, and comparing the two. And then obviously if all of a sudden there's more DC, it's going to turn on. That doesn't help me in terms of looking on its pins, because I don't know what the reference voltages are, what they referenced to, what, you know what I mean? It's open collector output, so I'm going to have to get the schematic for this thing. Yeah, just out of curiosity, I want to just quickly have a look and see if this op amp here is powered up. I'd say it is off the plus minus 15. Yeah, 30 volts, that's powered up. Yeah, well, I'm going to have to get the schematic for this before I go any further. I could, you know, quickly go over and just check every single transistor for a shorted these little transistors, you know. Yeah, I could do that quickly. But to be honest, if there is a little transistor that's shorted, there's probably more shorted down the line, because most of this looks like it's DC coupled. Some of it might not be, but I would say a lot of it is. So I'll go get the manual for this. Sorry, schematic. And I'll be back again in a moment. Alright, so I downloaded the service manual. Service manual doesn't look like it's much help. All it's got is board layouts, what components make up the thing. Like, I can't see the components here. And there's no actual like schematic diagram. And then there's a bloody repair flow chart, which I'm really not interested in. Anyway, so I'm just going to start using my brain. Look, that's 4 comparators in one package. There's a bunch of resistors around it. There's 4 transistors here. I'd say, well, maybe they're transistors, maybe there's some sort of adjustable reference or regulator or something like that. Who knows? I'd say they're setting up 4 reference points, and the other inputs are going straight off to PNP side of one channel, PNP side of the other channel, NPN side of one channel, NPN side of the other channel. That's what I would assume. So going off of that, this black wire, so this is one speaker output, this is the other speaker output, this black wire is the common, and then it's got, you know, two different voltage rails, lower voltage rails and higher voltage rails. I might have picked up the wrong wires, but yeah, it's whatever you call it, class H, class G, I think it is anyway. Anyway, so first thing I'm going to have a look at is I'm going to look between the output wire, the common ground wire, and each output, because like I said, DC will feed through even with no power. So we've only got 1 millivolt. Oh, sorry, I wasn't making contact. So we've got 30 millivolts on one channel. Alright. On the other channel, we have, oh shit, 400. Well, there you go. I think I've hit this one on the nail already. So at this point, I'm not even interested in trying to work out its reference voltages and its inputs and all that. I'll stick my meter into the common lead just quickly, just jam it in there. Let's just have a quick look what's on here. Actually, let me get its data sheet back up, because I really don't know its pin out. How did that disappear? Oh my god. A103391 VA. There it is. Oh my god. My internet's not connected. My phone went flat and turned off. I thought it was plugged in, but it wasn't. Well, it was, but whatever. You know what? We can work this out ourselves. 0.636. 183, 183, 2.9. So I'd say that it gets its power from the two middle pins, but I could be wrong. There is 3.5 volts across them. I really should just go get the data sheet for this. It will make it a lot easier. I think I'll do that in a minute. I've already got a very strong suspicion that we have shorter transistors in here, because well, the op amp could be buggered. It could be coming from the start feeding through, like I said, but yeah, I got a strong suspicion. That's very interesting. The first output of the op amp has got 22.7 volts. Reference to ground. What's the second output got on it? The same. Alright. That might be perfectly normal. I'm going to have to get the data sheet for this chip. Then I can just, it'll be easy for me to work it out. Then I could just go, I guess, you know what, screw it, let's just go start blindly checking transistors. I already checked all the main power devices in the other video and there was no shorts on them. So I'm thinking, let's just start testing all these little ones. All right. I don't know why that's producing a solid beat. It's a bit weird. Oh shit, I still got this powered up. I'm a fucking idiot. Wow. That's not going to produce the right result, is it? Sorry, this is a PNP device, my bad. Back to NPN. No PNP. This one will be NPN. PNP, sorry. I set them all back to front, but all good. I'm going to try these. We'll test all the larger ones first that are going to be buffers or pre-drivers or whatever. Part of bias networks, whatever. Alright, so none of these big transistors are shorted. We can start checking the small transistors. I wonder if these diodes are in part of the bias network or something. It's worth giving them a quick check. Alright. Wonder what these transistors up here are doing. Are they transistors? K246. I'm not sure if they're JFETs or are they transistors. Or are they MOSFETs? I'm not sure. The transistors. Well, that off the bat's interesting. No, it's not. These might these might be MOSFETs. Well, I think they're actually transistors. Alright, well, they're checking out good. I want to get the data sheet up for this IC, because what I can do is I can work out which pins it's got its references on, have a look at them, and then have a look at all the other pins, and instantly one of the pins will be higher voltage than all the other inputs, and that will go off to one NPN set or one PNP set of each channel, and then we'll know that we're in that quadrant of the board, and it'll be a lot less looking. Or the op amp. But yeah, I'll just stop the video because I've got to grab my phone, put the hotspot on. I want to go get a drink. Yeah, I'll be back in a second for you guys. You know, I was just having a look at my camera, like my phone screen then for a second. I realised I don't know if the if the multimeter was in focus then. Actually. So just to show everybody. Just want to have a quick suss and see if this... What on earth was that? Something just flashed in here. That was so weird. What the hell? Like a light turned on or off. Oh, I just want to see if this ground here is also this ground here. No, it's not. Okay. Anyway, this is one speaker output, as I was saying, and this is the other one. Ground to this one gives 25 millivolts. Ground to this one gives 20 millivolts. I must have had one of those connections there loose, and I was causing offset myself the first time I measured that. Oh no, there it is, 398 millivolts, see? So from ground to one channel, there's 400 millivolts of offset. From ground to the other channel, there is... Oh, it's actually the same. What on earth? I thought I was onto something. Damn it. Maybe this is going to be a bit of an annoying one. Alright. Well, that's interesting. I wonder if there's something wrong with the switching power supply too. That's another possibility, because it's got multiple sections that have to power up. And yeah, there's a good possibility that some, you know, like the section that powers the output is not working. I think given the condition of everything I've seen so far in here, I think I might actually have a quick look at the power supply board, just very quickly, before I go and spend like 2 hours trying to find a circuit diagram for the bloody thing. I really don't feel like doing flowchart bullshit. Yeah, this has got a few stages. Yeah. This thing's actually been exposed to some sort of dust and moisture at the same time, and it's, for those that have worked on enough stuff, you know what I mean. When dust and moisture combine, it creates this certain oxidation that only dust and moisture can create, and it sort of wicks its way up component legs and everything. And I'm seeing it in the ends of resistors and everything on this board, eh? I just want to check the value of a couple of these. God, that's going to take a year. Alright. I'm going to start checking a few things on here. So, we've got some regulators, 5 and 12 volt regulators. Actually, you know what I might do? Let's power up the power supply on its own. How can I bypass power switch? So we're going through some inrush limiting resistors. Jeez, 26.8 ohm resistors in parallel. That's a bit wasteful. Oh. Hey, is that inrush limiting? Oh no. Sorry, that's not inrush limiting. That's actually going to this 240 volt relay. 24 volt DC relay. What? Oh, that's not. That's getting powered over here. Yeah, it's inrush. Oh, okay. I see what's going on here. Yeah, it is. It's inrush limiting. The relay comes on and shorts those. I was thinking as if there wouldn't be like an NTC or something there. You wouldn't just put two 6.8 ohm resistors and leave all that current going through it. So our input path is here. So one wire here, one wire here. Okay. So if we use this brown and this yellow, we can bypass the switch and we can just power it up. I've got my dim bulb there. Then I can just see if all the rails are present on this. That way answer that question without me wasting my time testing components and going through a whole load of bullshit basically. Let's grab some power. Are these going to reach? Yep, they will reach. Which side's the resistors? That's going to be active, I'd say. Not that it really matters, but I always like to try and do everything as properly as I can. I'll put it on the dim bulb, not because I'm worried about it blowing up, but I just want to limit the current just a bit, so if something touches, we don't go bang, just a few globes will light up. It's always better when bulbs light up instead of things going bang. Alright, that flash was just the dim bulbs. I've got 100 watts worth of dim bulbs in series with it. Now I suppose I need to tell it to turn on. Actually no, this thing just comes on when you press the power button, I'm pretty sure. So let's see if we've got any rails. Yes, 85 volts, 42, 85, 42. Okay. What? Wait, can you guys... Sorry. I'm really sorry about this. I'll do that again. You can see where I'm probing. Yeah, okay, cool. Alright, 85. Sorry, 42. 85. 42. Oh, sorry, 85 again and 42. Alright. How can I get to this and read it at the same time? I guess I can just use the ribbon cable. Don't worry about me touching a single heatsink. I'm not grounded. So if I touch something live, it doesn't matter. I can literally grab live and just sit here and hold it, you know. It's not going to do anything to me. Wouldn't do that with two hands. Why is this? Oh, it's all labelled down here, I see. Okay. So it's the last three wires we should have our 15 volt rail on. Yep. Alright, let's see if we've got our power rails for the front board. We've got the same plus and minus 15. I'd say it's the same rail, but I'll just check one of them just in case it is sourced from a different regulator. I don't feel too comfortable about that. Let me just see if I can get in here with these, otherwise I might have to put some bits of wire in the socket. I don't want to short one of the pins to one of the heat sinks. That could possibly end quite badly if the devices on the heatsink are not insulated. Oh, really? It looks like, yeah, that should be plus or minus 15 again. Hold on. Oh no, it's there. I'll just check the other way. Yeah, no, that's there. Alright. Now this is another plus 15 and a 12 up here. I'm not going to be able to get to that without putting wires in there. So I'll grab a couple of bits of wire. But so far it looks like there's nothing wrong with the power supply. Power supply is up and running. You know what? I'll just use these same 3 bits of wire. That'll do. D ground, L ground, ground. So we've got 1, 2, 3, and 4. That's plus 5 and plus 12, which should be referenced to this ground over here. If it's not, it'll be referenced to one of those top 2 pins this side of the red wire. Alright. Yeah, the 5 volts is there. I'd say 12 volts is there as well. Well, unfortunately, let me just get the danger out the way. Unfortunately, I guess not unfortunately, but yeah, it doesn't really bother me really if I've got to fix the switch mode power supply or an amp. I guess both are just as annoying. So yeah, well, we know it's not the power supply. So there's that. So that's up and running. With all of its rails. Alright. I always thought the problem was on this board from the start. And you know what they say about your gut instinct, it's usually right. And in my experience, my gut instinct's always right, so I'm going with it. I've got the data sheet here now. Yeah, this is a weird thing. Alright, well at least I've got the pin out and everything. VCC and VEE. I have to power this board back up again. I'll keep it over a bit more to this side, that way I can have my multimeter on the left where it's easy for me, but you guys can still see it. I'm going to have to power this board back up again because I need to, first thing I want to see is the power to that quad comparator, and if there is, then I'm going to start sussing out its levels and see which input's different. So it should be yeah, it's that package. Oh, hold on a minute. There's no identification as to what end of the package is which. What? Well, it's 3 pins up on each side, so we'll work it out. It's either that pin there and that pin there. Yeah, 30 volts across it. I'd say that's its power rail. Yeah. Okay, so we know where it gets powered from. Now, its outputs, these 4 pins here, I don't know what they reference to. Let's see if they reference to the common ground. Let's see. Output 1's got 6 volts on it. Output 2's got 6.1. Output 3 and output 4 is still roughly the same voltage. Okay. Well, let's have a look at all the different inputs. 0.6. So the way it goes, we've got positive, negative, positive, negative, positive, negative, positive, negative for the inverting and non-inverting inputs. 0.6, 0.186, 0.186. 2.9, that's interesting. There again. 185, 185, minus 613. I'm going to have to get the schematic for this in. Oh well. Let's go check all the little transistors in since we're in this deep. Still powered up again. I've got to stop expecting to get the correct readings whilst I'm powered up. It doesn't work like that. I'll just go back over these in case I was getting false triggers. Because it's entirely possible to have an open transistor and have 0.6 volts across it from some other part of the circuitry and the multimeter just sees that. Or a resistance that drops enough voltage for the multimeter to again think it's a 0.6 volt drop. That one side of that transistor's a little suspiciously high. I mean, these are all... Where's another one saying? Oh, okay. Those ones are like that. That's almost 800 millivolts. It's in circuit, so it's hard to say if that's other things. You know, there could be a capacitor with charge in it contributing to that. Yeah, no, I'd say that's just how those transistors behave. This could be a MOSFET, but no. I don't think there are going to be any FETs in here, but it's possible. Unless this is an NPN. It's an NPN. Alright. Thought that was open. Did I test these two? I don't even remember. Oh God. Can't remember if I did this one ever or not. It's hard to do this without getting my head in the way. What the? I got my pin out wrong. Might have found something off. No. Just had the wrong pin out. Hold on a moment. Something's up here. Is that marked the same as the others? No, it's different to all the other ones I've tested. So these two might be MOSFETs. There's another one the same here. I'm going to say they're MOSFETs. That's kind of interesting. I'm not even seeing a body diode. Not being able to charge the gate and turn them on. Not that you can do that with every MOSFET, but wait, these are completely open in every direction. Eh? Well, I guess there are FETs that don't have a body diode. JFETs don't have a body diode, do they? What are they? There's two more here. They must be some sort of FET that doesn't have a body diode in it and obviously needs a higher level than the small bias voltage that's coming out my probes to turn on. I can't imagine them all just being open like that, you know. So we'll ignore that and continue on with the transistors. I'm getting tired, I'm going to have to go to bed soon. It's 12:31 AM. I always end up late. Hold on. This is a driver transistor. Oh no, it's fine. Wrong pin out, ladies and gentlemen. Don't you hate that? You know when you're probing around something and you're like, yeah, I found a broken part. And then you change your probes around and it tests good and you're like, oh fuck, it was just a pin out. It kills, doesn't it? It kills, I know. I've experienced it plenty of times. You know what I hate? When they mark the same designator for MOSFETs and transistors. So you don't know, they're all just Qs. Oh, hold on a second. Oh, why couldn't it be you? Finding a shorted or open transistor or leaky, funny transistor would just be the dream, wouldn't it, you know? I don't know if I spotted that one up here. I did. Well, if I didn't, it tests good. That was a bit high on that side. Now that is actually strange. Let me just find another one of those exact same ones. Huh? Very suspicious. Well, this is interesting. Hold on. What part of the circuit is this? Do we have a symmetrical circuit on the other side? No, we don't. It seems... Oh, it could just be laid out differently. One moment. Oh no, we do have it. It's laid out differently, I see. Yeah, we've got the exact same transistors over here. So let me just... The one that goes to the capacitor, that red funny. That's supposed to test as... I don't remember seeing that, but okay. Okay, well that is actually the same on both sides. Alright. I'm going to have to get the schematic for this. Where's my little torch? Great, torch in flight. Like me, I'm getting tired too. I'm going to have to find a schematic diagram for this one. Alright, well, I'll leave it there for tonight because I'm getting tired and I don't feel like wasting more time without a schematic. Let's check these resistors. What do we got here? I don't see much point because the output devices didn't test short, but I think this is going to be a pretty pointless endeavour, to be honest with you. In fact, I'm not going to waste my time. I'm just going to get a schematic for this. There's nothing that's jumping out at me. I I thought there was a different offset voltage that was getting fed through from the input stage to the output at first, but it turns out it's the same on both sides. That comparator's got a different level on one side, but it also has the same level on the other side on one of its inputs, so that's probably completely normal too. Unless there's the same problem on, say, like the same half of both channels, or both halves, like NPN and PNP half of one channel, are both gone, and that's what those two higher levels are. But again, I didn't test any blown transistors before, so I think I'll just get a schematic, go over the schematic, because then it'll make sense to me. I mean, it's just an amplifier. Plus I'm getting tired too. My brain doesn't work well when I'm tired. So I'll leave that there for now. I'll upload this video too, and yeah, I'll get a schematic and I'll see you guys in the next one. Thanks for watching. Also, please like and subscribe. I'm really trying to grow the channel. I'm a new channel, and I'm just trying to get my name out there, so if anyone can help me out, I'd really appreciate it. Thanks guys and girls. I'll see you in the next one.